Welcome back. In this video tutorial, we are going to be looking at how to test independence of errors in SPSS, and the method of analysis or the statistical test that we are going to use to conduct this particular test is called Durbin-Watson statistics. Please take notes, this test can also be reversed to as a serial correlation test or autocorrelation test. But before I dig deep into how to do this in SPSS, let me quickly give you the background information that you need. Please take note that autocorrelation, serial correlation is one of the assumptions of linear regression model. So if you want to make use of linear regression method, you need to check for this particular problem and ensure that your model is free from the problem of autocorrelation. That is, the observations are not correlated, or the residuals of the present and past errors are not correlated. Autocorrelation occurs in time series or ordered data where errors from one case are correlated to the error from the next. So you can also say that autocorrelation in the residual is a situation whereby there is a relationship or dependency between the current and past error in a time series. But in the case of ordered data, then you can say errors from one case are related to errors from the next. So there is need for us as an analyst or for you to check whether the residuals or the error in a regression model are independent of each other. I've said it earlier that we are going to be making use of Durbin-Watson statistics to check for this particular problem. Now let's take a look at the hypothesis statement. The non-hypothesis is that the errors are independent, that is, there is no problem of autocorrelation, while the alternate says that the errors are autocorrelated, that is, there is a problem of autocorrelation. Now let's quickly take a look at the decision rule. Please, when you have your statistics, you need to take note of this value. The DU you are seeing there stand for Durbin-Watson, and a situation whereby the DW here stand for Durbin-Watson. When the value of the W is 2.0, it indicates or suggests that there is no problem of autocorrelation. So in that case, you can proceed with your analysis. But in a situation whereby the value of the DW is less than 1.5, then there is a positive autocorrelation. Also, in a situation whereby the value of the DW is greater than 2.5, then we say there is problem of negative autocorrelation. So the general rule is very simple and straightforward. Just make sure that the value of the Durbin-Watson statistics is between 1.5 and 2.5. When you have a value between 1.5, either 1.5, 1.6, 1.7, 1.8 up to 2.5, then you are certain that there is no problem of serial correlation in that particular model. So you may need to memorize this particular decision rule. The most important there is the general rule, between 1.5 and 2.5, whether positive or negative, it is a problem. So now let me take you through how to do the analysis in SPSS. To do autocorrelation test in SPSS, you must ensure that you have your data sets uploaded to your SPSS, and once you upload your data test, then you can check for some other tests before it's something like a multicollinearity, which I'm also going to show you in the next video. But to do serial correlation, autocorrelation, or independence of error test, you need to identify your dependent variable as well as your independent variable. Then once you have those ones listed down, then you need to go to analyze. You go to analyze. This is analyze. You click on analyze. Then from analyze, you move to regression. Look for regression here. This is regression. And once you see regression, you just select linear regression, linear. Then you will have this particular window open. If you look at it very well, you will notice that here we have dependent, and here we have independent or independent. And don't forget that I said you should make sure that you distinguish between your dependent and independent variable. So here, what is going to be our dependent variable? Let's make use of a continuous variable, a continuous data. Let's use weights. Let's make use of weights as our dependent variable. Then once you click on it, you move it here. Let me do it again so that you can see it. You click on it, then you click on this arrow, then you move it. The next thing we need to identify or to select is our independent variables. So here, let's make use of current salary as our independent variable. You move it here. Then we can also select let's select rent paid by the respondents. So now we have two independent variables. Once you select these two things, then you go to statistics, you click on it. This particular one window also will open. The next thing you need to do is to select Durbin-Watson here. You just click on it. In case you need any other statistics like R square, change, as well as descriptive, you can just select it, but our priority here is the Durbin-Watson statistics. So the next thing we need to do is to click on continue. Once you click on that, then you can, in case you want to make any adjustments here, you can do so as well, but we are only interested in this particular one, and also we are only interested in one block, so we don't need to explore this part and we don't need to explore the other ones. But the most important thing that you must do here is to identify your dependent variable. You move it to the column, then the independent variables. In our case, we have two independent variables: salary, income, current salary, which is income, as well as rent. Then once these two things variables have been selected and you have also selected Durbin-Watson under statistics, then you click OK. Once you click OK, the results will come up. Then you look for the model summary. This is the model summary. Then here we have R, we have R square, we have adjusted R square, we have the standard error of the estimate, then we have the Durbin-Watson statistics. If you look at it very well, the Durbin-Watson statistics is below 1, is even below 1, and the general rule is that when we have our Durbin-Watson statistics that is between 1.5 and 2.5, then there is no problem of serial correlation or autocorrelation. In this case now, this model suffers from the problem of autocorrelation. Why? Because the Durbin-Watson statistics is below 1.5, and when it is below 1.5, we say there is a positive autocorrelation. Don't forget, when it is below 1.5, there is a positive autocorrelation. So that is how to check for serial correlation or autocorrelation in SPSS. It is very simple. You load your data, you go to analyze. From analyze, you select regression, then linear, identify your dependent and independent variables, you move them to the right box, then you click on statistics, you make sure you check the Durbin-Watson statistics, continue, then you click OK, and the next thing is that you have your results. So with this, we have come to the end of this particular video tutorial. Please, if you have any question, you can just drop it in the comment section. Also, make sure you check our channel. We have released several videos on how to do one test or how to conduct one analysis or the other in SPSS, in E-views, in Stata, as well as R. Thank you.